Hi, in this lesson we need to finish off our work on igneous rocks. So we're looking to tie up all the loose ends at the end of theme 5. So you'll need your theme 5 booklets. We're going to start work on page 21. Okay, let's go. The first job is to complete this flow diagram. You've got a list of words there at the bottom of the page that you need to fit into each of the boxes here. Some of the boxes aren't particularly large, but it's fine. Just write in the words there or thereabouts. Okay. Each of those words will occur in the same number of times that you see it in the table. Once you've done that, it's time to revisit for the last time what's in a word. We should now be geological experts in each of these terms. Okay, so make sure you've got a really good definition for each of these. If your definition is good enough, you can just draw an arrow taking you through to the end. Okay. Remember, all of these words are the ones on your specification. Okay, so press pause now and have a go at that. Okay then, let's see what you've come up with. So our first job was to complete this flowchart. So if we start, igneous rocks form when magma does one of two things. It's either erupts via volcanic activity to become lava, which will then cool and solidify rapidly to form an extrusive igneous rock. Of course, if it cools and solidifies slowly within the crust, it'll form an intrusive igneous rock. Now we classify igneous rocks by their mineral composition and mineral grain size. So coarse grains form when molten rock cools slowly, and they can be fine grained when molten rock cools very rapidly. Mineral composition then is divided up by silica content. So it could be, well, in this table they've called it felsic. That's an old-fashioned term. We'd use the word silicic. Silicic rocks with a high silica content tend to be light-coloured and low density. Ultramafic rocks, on the other hand, tend to be dark-coloured and high density. Now, examples of rocks like this, like the mafic rocks, if they're volcanic and fine-grained, they're going to be basalt. If they're coarse-grained, plutonic, which is an old-fashioned word for intrusive, it might be a gabbro. The silicic rocks, we can have rhyolite, is our fine-grained volcanic rock, and granite is the coarse-grained intrusive rock. So those are the answers for our flowchart. Make sure you've got those in the right place. Okay, I asked you as well to revisit what's in a word. So we've got all our different igneous terms, some of which are probably very familiar to us. Others were definitely new to us in this theme, particularly that one. So let's just go through what each of these mean. First of all, magma. Magma is molten rock. Usually molten rock below the surface, but it's rock that's been heated up, usually under pressure, usually with gas in it. There's a combination of different things in there, but the key feature here, It's molten, hot, liquid rock. Picture from my holidays there, honest. A lava flow then is where we find magma at the surface. So this is a flow of liquid rock across the Earth's surface. This particular example, we can see an A'a lava flow here in Hawaii. At the core of that, there is molten rock, although it's cooling down and slowing down at this point. Still a lava flow. A sill is an intrusive igneous rock, and it's where the intrusion follows or is concordant with the layers in the country rock. This particular example, really clear one, that's the dark rock here is the igneous one. This is from Antarctica. A dike, like this one in Tenerife, is also an intrusive igneous rock, another sheet-like body. The grey rock here is the igneous one. And here, the igneous intrusion is discordant, or it cuts across the layers in the country rock. You can see here the layers are gently inclined to the left. The dike, though, is vertical. A pluton is a large mass of intrusive igneous rock, a crystallized magma chamber, if you like. This particular example, Half Dome in Yosemite, is an enormous pluton. The surrounding country rock here has all been eroded away, but this rock is incredibly hard and has resisted that erosion and makes this mountain. A volcano is simply a place where magma gets to the surface. This particular example has a volcanic cone. However, it doesn't have to have a cone, it doesn't have to be a mountain to be a volcano. A volcano is simply a place where magma reaches the Earth's surface. Porphyritic is where we see crystals within an igneous rock of different sizes. This is a view taken down a geological microscope. So we've got some very large crystals here, probably about a couple of millimeters across. The scale bar at the bottom is 0.5 millimeter. These are crystals of olivine. The bright coloured one is olivine. The brownish coloured one is augite. Those crystals are much bigger than the crystals surrounding it, which are mostly feldspar. There's some other bits in there, but mostly it's feldspar. These two sizes of crystals here, the very big, very well-formed crystals here, you can see they've got nice straight crystal edges. They cooled slowly. The finer-grained crystals surrounding them, what we call the ground mass, cooled more quickly. The bigger crystals here are called phenocrysts. Phenocryst. Phenocryst. Okay. That brings us to the end of theme 5. There's the exam practice questions as well for you to have a go at. But we've now covered our theory about igneous rocks. We are going to revisit the idea of volcanoes, and particularly in terms of volcanoes as geological hazards. But that's the subject for theme 8. Our next theme looks at metamorphic rocks. I'll see you then.